You may use the chat for any comments or questions that we'll entertain at the end. And without further ado, Professor Mychael Smith.
Hi. So I guess the first thing I want to say is my motivation for doing this presentation was for my own benefit. I really wanted to learn more about some of the contributions of some Latinx mathematicians. So I thought this would be a good opportunity to do some research and find out what I could learn. So let's see. How do I... I'm not able to switch my slides. Oh, there we go.
At the bottom left, there you go.
Okay, so I'm going to start by just kind of telling you what I think of mathematics, the way I think of it. So I looked up the definition on Google just to see what it says. And Google says that mathematics is the abstract science of number, quantity, and space. So I don't exactly think of mathematics this way. The way I think of it is using logic to study patterns, shapes, and structures. So for me, these are two of my favorite shapes that I like to study in math. And these two shapes, the first one above is called a torus. So you can think of this torus as the surface of a donut. And the one underneath it is called a Klein bottle. So these two shapes are very interesting to me. And they're also meaningful to me because when I was an undergrad, the way I really got started down my path of studying mathematics was I had a professor, you might know him, you might have heard of him. His name is David Pengelly. He was at NMSU. He was an algebraic topologist, and he got me interested in algebraic topology by showing me these pictures and telling me all the wonderful things that we could study about them. But unfortunately, if you look into some of the history, what you'll notice is that a lot of mathematics has been dominated by white men, like many other fields of science. And it's actually not easy to find a lot of well-known, famous Latinx mathematicians. And even today, even though it's been improving, there's still sort of a severe underrepresentation. And for me personally, I come from a Mexican-American family. And it was important to me to sort of understand some of the contributions from people that come from my culture. And like I said, this was really one of the main reasons that I wanted to do this presentation. So I was looking in my calculus book that I used to teach Math 191 and Math 192 here. And a lot of the contributors that they mention in the book are mathematicians like Gauss, Euler, Newton, and rightfully so because they did contribute a lot. But it's very rare that you find in textbooks that are geared towards first and second year math classes that they mention mathematicians who are Latinx. So I found this to be kind of unfortunate. So what I did was I just did some research on some other mathematicians that you might not know about or that students may not have seen, but have some very important contributions themselves. So I'm going to try to go sort of chronologically from oldest to most modern. And I'm not restricting to just Mexican mathematicians or Mexican-American mathematicians. I'm going to try to cover sort of a spectrum of Latinx mathematicians. So this first mathematician that I'll tell you a little bit about, his name was Pedro Nunez, and he was Portuguese. So I couldn't find much about his early life, but he did move to Spain, and he started studying mathematics at the college level at a very young age. And something interesting that I learned about him is that he was Jewish, and he suffered from anti-Semitism. And this resonated a little bit with me because during today's climate, there's a lot of racism that we see, even micro racism that's maybe not as evident. And then there's also racism that's not so micro, that's kind of major. And a lot of our underrepresented students suffer from this too. So here, this was in the 1500s, he was Jewish and he was suffering some of the similar kind of problems that a lot of our students are still suffering from today. So his contributions, however, were pretty interesting. And one of the contributions that I found to be interesting was that he contributed to geometry. So there's a problem that he was interested in solving that involved taking a location. So you take a location on Earth, on the surface, and you want to figure out which day of the year that twilight is minimized. So the shortest amount of twilight. So the interesting thing about this is that he was able to solve this problem using only geometry. So he could take any position on Earth and not only find out which day of the year had the least amount of twilight, he could also tell you exactly how much twilight there was on that particular day. So what I found interesting about this is that this is an optimization problem. And typically you would use something like calculus to solve this. But calculus wasn't developed until a few hundred years later. And even with calculus, many mathematicians still had trouble solving this problem. Even some famous ones that you'll see in calculus books. So in particular, Nunez was able to figure out which day twilight was minimized. And he was also able to tell you how long twilight lasted on that particular day. Even with calculus, from what I understand, some mathematicians were able to figure out which day twilight was minimized, but still had trouble figuring out what exactly the length of twilight was on that particular day. So I thought it was very interesting that with 200 years less of technology, he was able to solve a problem that still gave people trouble hundreds of years later. Okay. So I'd like to move on to the next mathematician that I learned about. So this mathematician was named Julio, Cesar, and Mayo and Sosa. This mathematician was Brazilian. And what made me want to learn more about this mathematician was that if you look up what his contributions are, he was known more for his teaching, or at least as much for his teaching, as he was for his research in math. So given that we're at a community college and our primary responsibility is teaching, I found it interesting that this guy took such an interest in teaching when oftentimes a lot of researchers, they spend more time working on their research than they do on their teaching. So I couldn't find if he was a first generation college student, but what I was able to find was that his family came from poverty and that his father was a civil servant. So I didn't say if his father was educated, but his father did only have a modest job with a modest salary and had to take care of his family of 8 or 9. And what I also found interesting about him was that he struggled with his math classes, like many of our students do. And later on, he attributed his struggles with the fact that his teachers were dedicated to just lecturing. And by now, many of us know that just straight lecturing in class is oftentimes not the best way to get our students to learn. And he was actually a victim of this himself. So he was actually a pioneer in the scholarship of teaching and learning. He might not have told you that, but I feel like he was, because he did things that people are doing in more modern teaching environments that people just weren't doing at the time. So in particular, when grading, he didn't think of grading as being as strict as a lot of people think of grading. He thought of it as more of a holistic approach. And he even made a comment at one point where he said, well, if we're grading on a scale of 0 to 10, why would I ever give a student a 0 when there are so many other great numbers to choose from? And another thing he did, which I found interesting, was that he was one of the first math professors to use active learning. So these days, many of us know that using active learning techniques is a great way to get our students to learn. And it's a great way to have students learn from each other. So with active learning, you give students exercises to work on, and the students work with each other and oftentimes help each other to solve the problems. And he believed that this was the best way to learn, because he would use the best students that he had in class to teach the other students. And he would often say that by the end of the semester, all of the students would be passing, which is great. So another thing about him is that he was an author, but he wasn't just an author of pure mathematics. One of his most famous writings was this book called The Man Who Counted. And this book, although it has mathematical content, the audience for this book is a general audience. So you don't have to be an expert in math to read this book. And this book is known to have increased the interest in mathematics from a non-mathematical audience. Something interesting about him is that if you look at the author of the book, it's a different person. So for some reason, he used a pseudonym of a fictitious Arabian mathematician as the author of his writings. So I don't think people know exactly why he did that. Maybe he just thought that it would be funny. But this book is still in print today. And after doing research on this, I think I'm going to try to read it sometime soon. Okay. So I'd like to move on to the next mathematician that I learned about. So this mathematician was Victor Newman Lara. I see something in the chat. I think we're supposed to wait till the end for that, though. Is that right?
Yes.
Okay. So I'll continue with this mathematician. So I think this is the first Mexican mathematician that I've talked about on this list. So this mathematician did his studies, including his undergraduate degree and his PhD at UNAM in Mexico City. So that's the National Autonomous University of Mexico. And this mathematician caught my interest because his specialty was a field of math called graph theory. So graph theory is an important branch of mathematics, but the thing that I like about it is that it's very accessible. So I've actually done a couple undergraduate research projects recently in the last couple of years. And I was able to give students problems in graph theory. And these students didn't have any knowledge of mathematics past maybe pre-calculus or calculus. But because the field is so accessible, they were able to work on the problems and make progress, even with very limited knowledge of mathematics. So in particular, Victor Lara studied directed graphs, which are combinatorial gadgets. And he was one of the founding contributors of the theory of dichromatic numbers. So I'm actually not familiar with what dichromatic numbers or directed graphs are. They are very similar to what are called chromatic numbers of graphs that are non-directed. And that has something to do with how connected a graph is. Okay. So this sounds technical, and this wasn't really the point of the talk, to talk about what exactly his results were. But the important thing for me is that his work, although mathematical in nature, his work was based off pure mathematics. Applications have been found to other fields of science like computer science and economics. Okay. So I think mathematics is always the most useful when somebody finds a way to use it outside of mathematics. Okay. So the next mathematician that I want to talk about, I actually had the most fun doing research on him, partly because I already knew quite a bit about this one. So before I talk to you about him, I should tell you a little bit about the field of mathematics that I study. So I study a field of mathematics called algebraic topology. And the short way of thinking of this is it just uses algebra to study objects in geometry. So on the left side, you see a picture that you might encounter if you look in an advanced algebra book. And on the right, you see a picture of an object that you might find if you open up a book on topology. So algebraic topology is sort of the connection between these two fields of study. And the next mathematician that I want to talk about was an algebraic topologist. In fact, a very famous Mexican algebraic topologist. So Samuel Gittler, he usually goes by Gittler, Samuel Gittler. Everywhere that I've seen him talked about, it's Samuel Gittler. I never see it with his full name. So he also studied at UNM, but he only did his undergraduate degree there. So he went to Princeton to study for his PhD with Norman Steenrod. And Steenrod is one of the founders of algebraic topology. So he's one of the original people who worked on the very field of study that I work on today. And something else interesting that I found out about him was that he worked with another Mexican mathematician named Jose Adem at a research institute in Mexico. And Jose Adem is another Mexican mathematician that I'm familiar with. And he was one of the people that made great contributions to the study of Adem relations in homology theory, which is something that I studied a lot when I was in graduate school. So some of his contributions. First of all, he published many results in algebraic topology. And along with Jose Adem, he was one of the more prominent Latinx researchers in algebraic topology. So between the two of them, they published a lot of papers, and a lot of their results are still used in calculations that algebraic topologists do even today. And on a more personal sort of thing that he did, something that was more relevant to me personally, is he introduced in topology, not necessarily a spectrum. The idea of these objects called spectra had already been around for a while, but Gittler invented or discovered a spectrum that became very useful called the Brown-Gittler spectrum. So he has a spectrum that's named after him. And I actually didn't know this last part until I started doing research on him. But this spectrum is actually used in a couple of concepts called the Siegel conjecture and the birdside ring. And when I was studying for my own PhD, I actually encountered these concepts, and they became great motivators for the work that I ended up doing for my PhD. So I didn't know this before I started doing research, but I found it very interesting and pretty exciting, actually, to find out that some of his contributions were directly related to some of my own work that I did in graduate school. And also, he was a co-author of one of my favorite books. So I study algebraic topology, but I like to study a very, like a subfield called homotopy theory. And Samuel Gittler, along with two other Mexican mathematicians, wrote a book that tries to study algebraic topology completely from the viewpoint of homotopy theory. So this book is one of my favorite books because it takes the approach that I like to approach algebraic topology from. So unfortunately, so far, all of the mathematicians that I've done research on or that I've talked about in this talk, they've passed away. I believe that Gittler only passed away about 5 or 6 years ago. The final mathematician that I want to tell you about, she's still alive, and in fact, she's still very young. So Pamela Harris, researching her was particularly important to me because she started off as an undocumented immigrant. My own grandmother started off as an undocumented immigrant. And we all know that students who are undocumented immigrants, they have obstacles that many of us who are privileged enough to not have that same obstacle, they have to face those obstacles, and oftentimes it's very difficult for them to overcome them. But Pamela Harris, she was undocumented, and because of that, she was not able to enroll at the University of Wisconsin. Instead, she was able to enroll at a community college, and she got her associate's degree in mathematics there. So sometime during her studies at the community college, she got married to a US citizen. And after that, she was able to transfer to Marquette, and she went on to complete her PhD. So her story is inspiring because she faced obstacles that most people in this country are not going to have to face. And she overcame all of them and has become very successful. So her field of mathematics is algebraic combinatorics, and she has made many contributions to that field. But I'm not going to talk about any of them because her main contributions are beyond mathematics. So in particular, back in 2012, she was a Project Next Fellow, which I found interesting because this last year, I also participated in Project Next. And this project is a great way for new faculty members to learn about new innovative ways of teaching. And she was herself a member of this project, and she has used all the things that she learned to become a better teacher. Since then, she has mentored several undergraduate research projects, and in particular, she has done these projects for other students who are underrepresented like herself. So one of her other sort of non-mathematical contributions is that she's one of the founders of a website called Lathisms. And this website, which you can find online, is dedicated to honoring the achievements of Latinx mathematicians. So if you ever get a chance, if you just Google Lathisms, their website will pull up, and they have lots of great biographies of various Latinx mathematicians, including newer ones who are only recent PhDs or people who are even still in graduate school. So one thing that I mentioned about her is that she is committed to her teaching. She works at a private liberal arts college. And in addition to her undergraduate research supervision, she's committed to her teaching so much that she has been awarded with awards. And I really do think that she's a great role model for faculty members that want to improve the representation of Latinx students in mathematics. So the last thing that I want to do here is talk about some ways that we can all be more involved. So in particular for faculty members, one of the things that we can do, even for students who are first and second year students, is encourage them to pursue research. Because I think many of our students in particular just are not aware of the opportunities that exist. Many of our students are first generation college students, and they just don't know that faculty are there to help them and that they can be this type of resource for them. A lot of our students don't even know that they can come see us in office hours. So I think we should do a better job encouraging students to pursue these opportunities. And also let them know that just because their grades are not outstanding, that doesn't disqualify them from doing research. Oftentimes students that get lower grades are still able to do effective research because it's two completely different skill sets. And for students, I don't know if there are any students in attendance. But as a student, you need to not be afraid to approach your instructors and ask them about these opportunities. There are many opportunities for REUs, and many of them are specifically targeting underrepresented students. Okay, so I've sort of reached the end of this talk, and I just want to do one last sort of shameless plug. So I've done undergraduate research, and what I've tried to do myself is try to encourage underrepresented students. So in particular, this is the first student that I did a research project with. His name was Diego Estrada. And we worked on a project for about a year. And at the culmination, he was able to present at the University of Arizona. And we found funding for him to be able to travel to Arizona and present without having to pay for anything himself. And at the same conference, I brought two other students who ended up doing a similar presentation at a later date. They were able to make the trip and watch Diego present and learn about all the undergraduates doing research. So this is the end of my talk. So here are just a list of the websites that I used to get my information. So I guess we should open up for any questions.
We had a question earlier in the chat. One of the, obviously mathematicians you spoke about, Professor, but I don't remember which one.
Can I see the chat? I actually don't know if I can see the chat.
Well, I'll read it to you. She's asking if it was written
Okay.
in Spanish, but I don't, Dr. Gonzalez, do you remember which one?
Yes, hold on. It was the one that was using Malva Tahan. Can you hear me?
Oh, that book? Yes, I checked that earlier. I'm pretty sure you can get a copy in English or Spanish.
Oh, okay. But he was just using the Arabic name as an alias,
Yes.
right? Uh-huh.
Yes.
And probably because during that time frame, right, where most of the origins, like of algebra, were in Arabic originally, or
it's
was that the connection?
It's likely that he was playing on this fact that a lot of the original algebra was developed by Arabs.
Uh-huh.
Yeah, that's probably why he did it. Mm-hmm.
But you can find it in translation.
Yeah,
Yeah.
yeah, it was definitely written in Spanish, but I think it's written in English too.
Uh-huh. Very interesting. I just had to ask that question, right? Just out of curiosity.
Right, yeah. I mean, that would make a difference to me too, because I can read Spanish, but it's very slow. I can't speak at all, but I can read it. So it would be a lot easier if I could read it in English.
Well,
So
I understand.
hopefully,
Yeah, I was more interested in the connection to the Arabic language, right? Like why they were doing that, but it makes sense.
yeah. And I think he just did it to be funny, because after reading about him, I got the sense that he's a very humorous person.
Uh-huh.
Apparently when he died, he left instructions for his funeral, and he said, "Please, nobody wear black because black is for people who are fancy."
Right. That's great. And the title itself is written in Spanish, so
Yeah, that
uh-huh.
particular copy that I put an image of, the title is in
Uh-huh.
Spanish.
Yeah.
Any other comments or questions?
Can you show us your reference page again, just so that I could quickly jot down? I mean, I can ask you for this as well, but
Sure. The first page or the second page? I can tell you what each of the sources are. So this first one is where I got information about Pamela Harris. The second was where I got pictures of the book,
mhm.
the Algebraic Topology. The third is where I got information about Adem. On the next page, the first link is where I got information about Gitler. The second one about Neumann Lara. The third one, Mayo Sosa. And then the last one was where I got some information about the book.
Okay, perfect. I may ask you to send me those.
Yeah, I can do that.
Yeah. This is the most complete list I've seen of Latin mathematicians, right? I mean,
Yeah,
amazing that
it's
they're
hard to
out there.
find them, but they are out there. Yes.
Yeah, very good. Thank you, Mychael.
Mhm.
Very interesting.
Any other questions, comments?
I'm not seeing any. Professor Smith, thank you very much.
Thank you all for attending.
Yes, and just for everyone's information, we did record this as well as all of our presentations, and they will be listed on the live guide that hosts this program and all the other resources related to Latinx. Once again, thank you, Professor.
Thank you.
You all have a great rest of your